Hi everybody. Today we are going to discuss some exam type of questions where you will be given some chemical reactions and you will be asked to suggest most suitable method to determine the rate of that specific reaction. So here are some examples. So let us discuss them. Number one, you can see here in the first reaction here, ethyl bromide or bromoethane is treated with hydroxide ions to form ethanol and bromide ions. Now you can see hydroxides are smaller in size, bromide ions are larger in size. So in this reaction, smaller hydroxide ions are replaced by larger bromide ions. So there will be a change in the conductivity. The conductivity of this reaction mixture will decrease with the passage of time because smaller ions can move faster but larger ion can move slower. So here the most suitable method to determine the rate of this chemical reaction is measuring decrease decrease or change in conductivity. Measuring change in conductivity. So this method or conductimetric method is the most suitable method for this chemical reaction. The next one is a reaction between magnesium and hydrochloric acid to give magnesium chloride and hydrogen gas. Here one of the product is gas. So the most suitable method for this one is by measuring volume of the gas. So we can determine the rate of this chemical reaction by measuring the volume of gas, which is here hydrogen gas. So the rate of the reaction will be equal to change in volume divided by total time taken. The next example is the reaction of copper ions with ammonia to form a complex. You know that copper ions are blue in color, but when it forms complex with ammonia molecules, ink blue or deep blue color is observed. Deep blue color will allow us to measure the rate of this chemical reaction, and the method will be colorimeter or colorimetric method, because there will be increase in the intensity of the color. So we can measure the rate of this chemical reaction by measuring increase in the intensity of the color. The next method is the reaction of peroxysulfate ion with iodide ions to form sulfate ions and iodine. Iodine is brown in color. So here we can use two methods. Number one is uh, colorimetric method. Basically, colorimetric method can be used here because iodine is brown in color. So with the passage of time, the intensity of the color will increase here in this case. Another method we can use here, that is titration, because iodine can be titrated against a standard solution of sodium thiosulfate to find out its concentration at different time intervals. Now come to the next chemical reaction, that is the reaction of ethyl ethanoate with sodium hydroxide to form sodium ethanoate and ethanol. Actually, this is base hydrolysis of ester. So we can find out the rate of chemical reaction by measuring the concentration of sodium hydroxide with a standard solution of an acid like HCl. So the best or the most suitable method to determine the rate of this chemical reaction is titration. The reaction of propanone with iodine. So in this reaction, the reactant iodine is brown in color and all the products are colorless. So we can use colorimetric method here to find out the rate of this chemical reaction. Colorimetric method will be suitable for it. The last reaction here is the reaction of nitrogen gas with hydrogen to form ammonia gas. All the reactants and products are gases. So here the most suitable method is to measure the change in the pressure. So the rate here will be equal to change in pressure divided by total time taken. The pressure will decrease with the passage of time in this reaction because on reactant side there are 4 moles and on the product side there are 2 moles. So this reaction actually proceeds with decrease in the number of moles of gases. So the overall pressure will decrease with the passage of time. So the method to determine the rate of this chemical reaction is by measuring change in pressure. Thank you and goodbye.